Welcome to the next laboratory exercise in soil mechanics, and today's exercise is the Constant Head Permeability Test. Now, the Constant Head Permeability Test is used to measure the flow of water through permeable soils like sands and gravels, and it allows a large volume of water to flow through the soil in a short space of time. Now, today's test is going to be conducted on this sample of sand, and the sand in this test is a uniform sand with a large grain size, so it's going to let water flow through quite quickly. But what does the constant head test mean? Well, constant head means constant pressure, and head is usually the height of water that the water has to fall from to generate the pressure as it flows through the sample from top to bottom. And we generate the constant pressure from a reservoir. If I just turn the camera up, and you can see the reservoir up here, filled with water, which we've added some dye to, so it's a bit easier to see in the video. How the test works is the water flows down through the sand and out through a drain here, and we can use the drain to measure the flow rate, in other words, measure the time it takes for the water to flow out of the sample using a stopwatch or, for example, your mobile phone. Okay, I have the stopwatch ready. Let's turn the system on. So I'm going to add some water to the tank. And then we're going to turn on the flow. And straight away I get a flow coming out. You can see the green dye there. So I'm going to start my stopwatch. And I'm going to time how long it takes to fill 1 litre in the measuring cylinder. And everything happens very, very quickly with this test. It's going to be over in less than 30 seconds. So there it goes, coming up to the top. You can just see it rising up the cylinder. Coming to the top now. Just keep an eye on that. And that is stopped at 28.5 seconds. And that's the time it takes for 1 litre to flow. We'll use that to calculate the flow rate in a couple of minutes' time. Now, the second thing that we measure, I'm just adjusting the flow there. If we turn the camera onto the piezostatic tubes here, and we just keep the cell in view, you can see that we have 2 tubes attached to the top and the bottom of the cell. So the top one is this one here, and it's recording a height here. I hope you can see that coloured water in the tube, and at the moment that's reading just about 37 centimetres. The other tube is attached to the bottom, and that's measuring the change in pressure as the water flows through the soil, which we can use to determine, to calculate the permeability. So the bottom tube is coming out here, and this is just here, it's just about visible where it comes into the tube at about 15 centimetres. So the difference in height there, the difference in pressure, is 36 minus 15, which is 21 centimetres, or 0.21 metres, and that occurs over a length of this in the sample. 2 tubes here are 10 centimetres, 0.1 of a metre apart. And that gives us a hydraulic gradient, a pressure gradient, as we measure the flow rate through the sample. And we can now use that to measure the K value, the permeability of the coarse sand. So what we're going to do next is do the calculations attached, associated with this test. Just turn off the flow there. And the key information which we need are the sample diameter here is 75 millimetres, or 0.075 metres. The diameter of the tubes is 5 millimetres, and the height difference we said there went from 36 centimetres down to 15 centimetres, and the flow rate then we had just, I think it was 28.5 seconds for a flow of 1 litre. So what we're going to do in the tutorial now is convert that data into a K value, which gives us the permeability of the sand that we've tested and the K value for sand can be quite high. In other words, it could be, K is basically a speed of flow of water through soil, and we could be talking about a couple of millimeters per second, and believe it or not, for soil that would be high speed. Okay, let's take a look at the tutorial together.